Rational expressions, multiply and divide. We're going to start a unit called rational functions. But before we get into all the function aspects, like graphing and application problems, what we're going to do is take care of some basics. We're going to look at rational expressions, consider how to simplify them, how to multiply, how to divide, how to add and subtract. These are going to be fundamentals so that we can actually work with the rational functions. Okay, a rational function takes on this form. F of x is going to be equal to p of x divided by q of x, where p of x and q of x are polynomials. A rational function is basically the quotient of two polynomials. Okay, now there's a little catch here that q of x can equal 0. Because if q of x is equal to 0, this would just be undefined. Okay, we don't really worry about that much. When we start getting into the graphing, we're going to consider what happens when the denominator becomes a 0, but that would not be a case where q of x just starts off as 0 to begin with. All right, so our first order of business is just to think about how we would simplify a rational expression. Okay, and this is a rational expression here. You have a polynomial divided by another polynomial. We just don't have it set equal to f of x, so technically we call this a rational expression. Okay, now when we simplify, we're going to be looking for common factors that you can divide out of the top and the bottom. And here's the most important point I can make at the beginning. X squared and x squared, those are not factors. You can't cross these out. That's not how it works. These are terms that are being added and subtracted with other terms. You have to look at it as a combined item. The entire top here is one combined item. It's one expression. Actually, this would be a trinomial. It is one expression. Okay, now what we can do though is we can change the way that this looks so that it appears as factors. Then you can take those factors and cancel them out if you happen to have something matched between the top and the bottom. All right, so for the top, to factor this, we're just going to think of two values that multiply to give us negative 15 and add to give us negative 2. And those values would be negative 5 and 3. All right, and then for the bottom, this is the difference of squares. It is going to factor into x plus 3 times x minus 3. And from here, if you have common factors, you can cancel those out. The x plus 3 and the x plus 3. Those cancel with each other. And this simplifies to x minus 5, whoops, that would be a minus, into x minus 5 divided by x minus 3. All right, so now that we know how to simplify by factoring, what we can do is use that technique to help make multiplication and division easier. Okay, recall that when multiplying fractions, it is possible and incredibly convenient to simplify before you multiply. Okay? Take this for instance here. You do not want to multiply your numerators and multiply your denominators. When you do that, I mean, take a look at the numerators. When you do that, you're going to end up with a quartic function, which we've already previously discussed is really hard to factor. Okay, if you multiply these together first, you're going to be creating a harder situation. So we're going to start with the concept of factoring. We're going to take a look at the factors that we have, and we're going to simplify. We're going to simplify first, and then we can multiply what we have left over. However, what we usually do is just leave the answer in factor form anyway, which makes it easier for everybody. All right, so the very first part here, let's go ahead and factor that. That would be a GCF. That would be a GCF. Both of these terms are going to have a 3x. So we can factor that out. That would leave us with 1 minus x squared. And this is going to be really important. We're going to come back to that in a little bit. Okay, for the denominator, we're going to factor by looking for numbers that multiply to give us negative 5, but add to give us 4. That would be x plus 5 and x minus 1. Okay, over here, what multiplies to give us negative 20, but adds to give us 1? That would also be a positive 5, and we get negative 4. Okay, and then the bottom, you don't really do anything with that, right? It's just 3x. Okay, so from here, everything that would be in the numerators would actually just multiply together. Okay, so all of these are factors in the numerator. Same thing for the denominator. So if anything matches in the top and the bottom, you can actually cancel it right now. For example, you can take out x plus 5. You can also take out the 3x's. Okay, so we still have 1 minus x squared, we've got x minus 4, and you've got an x minus 1. All right, now up here though, this is this interesting part there. If that were backwards, if it had said x squared minus 1, that would actually be the difference of squares, which would have this as one of its factors. And it is possible to rewrite this so that it does say x squared minus 1. Okay, now you can't just flip it around. That wouldn't be a rule that you could apply. But if you factor out a negative 1, it will allow you to flip it around. Okay, so I'm going to move a negative 1 out front. Basically what I did is I divided both of the terms by negative 1, which is going to switch their signs. The negative will become positive, the positive will become negative. But it looks better to rewrite it this way. And that becomes the difference of squares. So we get negative 1 times x plus 1 times x minus 1. Okay, and then we've got the x minus 1 on the bottom. From over here, we've got just that part, x minus 4, which you could place over 1. And now we can cancel these out. And in addition, you can actually just remove the 1, but you're going to keep that negative there. So ultimately, we get negative x plus 1 times x minus 4. All right, so division is basically the same thing as multiplication, but with one extra step at the very beginning, which is called keep, change, flip. What we don't want to get into is taking this numerator and dividing it into 7x. Obviously, that's not going to work out nice because you got a quadratic that you're trying to divide into a linear term. Okay, and then the same thing for the denominator. So we use a technique called keep, change, flip. You keep the first fraction as it is. You're going to change this to multiplication. And to balance it, you're going to use the reciprocal of the second expression. We're just going to flip this over. So keep that, change the multiplication, flip the second fraction. Okay, and we can do that at the same time as we factor, which will save us a little bit of time. All right, so the 7x is just 7x. Underneath that, we have a GCF. You can divide out 2. The division is going to become multiplication. We're also going to be flipping the second fraction. Okay, so for the top, this is a GCF as well. You can factor out an x. Just make sure that you place that on the bottom because we are flipping this over. Okay, now for the last part, what multiplies to give us 30, but adds to give us negative 11? That would be x minus 5, x minus 6. Okay, you need negative 5 and negative 6. All right, and then from here, you just cancel what you can, and that's it. These cancel. These cancel. You can even cancel this x with that x, and you're going to be left with 7/2. All right, we got one more example. And to be honest, the only reason that we have this example is just so that we can practice factoring by parts. That's pretty much it. Everything else about it is just like the other problems. Right here, you're going to pretend that that's over 1 so that when you flip it, okay, it actually looks like a fraction and becomes easier to flip. But that really doesn't make too much of a difference, and you probably already knew that. All right, so factoring by parts. 6x squared plus x minus 15. We need to find two numbers that multiply to give us a negative 90. That would be the product of the 6 and the negative 15, but also add up to give us a positive 1. Okay, 1 will be positive, 1 will be negative. Their difference actually needs to be 1. So that's going to be 10 and 9 with a positive 10. We'll then actually factor by parts. That's the separation here. The first two terms, you can divide out 2x, leaves you with 3x plus 5. So the other needs to have a 3x plus 5. And you can get that by dividing out -3. All right, so this is going to factor into 2x minus 3 times 3x plus 5. All right, so let's take that over to the problem now. The bottom, you don't really need to factor that apart. It is composed of a couple of 2's and a couple of x's, but we might not need that. Okay, now for the other one, this is we're going to flip. So we change that to multiplication. We're going to flip this, so the top will be a 1. The bottom, we have a GCF, which is just x. That leaves you with 3x plus 5. These match, so they're going to cancel. And that's pretty much it, except that this x is going to get to group with these x's. So we get 2x minus 3 over 4x cubed. You don't really need the parentheses there, just a habit.
Wait, there was.